Mothilal Marimathu. I'm a data cloud solution architect. I've had around 17 plus years of experience developing and architecting, designing, and productionizing end-to-end solutions across multiple domains and also across multiple cloud technologies. Um, Today, I thought I'll take up a use case where I could bring in all of you towards a modern healthcare platform, leveraging the Azure's tech stacks like Databricks, a factory, and then the Delta Lake, along with Snowflake and other technologies. So before I start, I really wanted all of you to, all of us to get into a page of what are we going to learn today or what are we going to talk about. Okay, as everybody said, technical conference has technical issues. Okay, so the agenda that I wanted to walk you all through today is, first thing is, we all know that we are all here on our data. So is your data model compliant? When I mean compliant, the basic understanding of how well is your data. Because without knowing how well your data is, you cannot construct or well architect a framework to build something. You need to bring data products and other things when you understand your source, target, the domain, and all that. So how was the architectural best practices that I followed up, which enabled us to build a well-architected framework? The first one is about how a data model is compliant. So I'll walk you through a couple of the steps in the next slides where we will detail about what were the best practices that we did across to. And when we go around, now that you understood the data, what is the next thing is how well is your ingestion framework? What is the data frameworks? Like you have batch process files, you have real-time data files, you have IoT, you have Internet over Things, sort of remote wearable devices. The data is scattered across in multiple formats, multiple sources, and how well is your ingestion framework? How well are you able to ingest the data? And how Azure Data Factory has been a ETL tool with a lot of its meta-driven frameworks and a lot of other templates that we have developed across, making it more meaningful to ingest the data. And once you have ingested the data, is your workload underperforming? Because processing is the heart of data. You have to see how Databricks is able to sort of process the data, analyze the data. You're able to bring in a lot of meaningful processes across. And here I'll be talking more about the Spark streaming or IoT devices, how a lot of data acquisition, custody, and things which were being helpful in terms of getting into the data. And then now that you've got your data being processed, there are today data from multiple providers. You have the same format of a data across with multiple people, the same set of data. It can be, how do you ensure that the identity matching is being table? So you have this UMPI, Universal Patient Identifier things, which is being able to map using referential sort of mapping algorithms. You're able to match that to a single identifier. So how Verato has been a solution which we have been able to get that. I'll be detailing it out over there. So now that we have moved all the data into the cloud, how is that the end of the digital transformation? You have processed the data, you've loaded, processed the data, you've got all the data inside, but is that the end? What is more onto it on terms of reporting, visualizing? How are you serving the data? How well was Snowflake, a data warehouse with the power of also with Power BI and other reporting tools? How are you being able to get that? I'll be able to show that. And after that, a data journey towards the destination. So all of this combined together along with CI/CD, DevOps orchestration engines, monitorings, as well as to analytics, AI, ML products. And end of the day, it is all about us to develop a data product. So here I will be able to walk you through how in a couple of my healthcare as well as other solutions that we have developed, we were able to walk through a complete end-to-end solution and identify it as a data product. So I would also show you a couple of portal walkthroughs, code snippets, so that you get a look and feel of each of those technical products, and then you're able to see through things on how we were able to get that into a architectural best practices. So as I said, the target audience here, I know we are all scattered here in a conference. It's quite a bit of people who are business analysts, architects, developers, quality engineers. Today, even data quality engineers needs to look at Databricks on how classified could their data be looked at? How can I look at templates of analyzing a data factory pipelines? So the necessity of all of us to learn across the technical stack is pretty important. And I've made it in such a way that teams of how a zero cloud experience people could actually get to learn things, which is the necessity of you to learn both the domain knowledge as well as the technical knowledge for you to get it. So here I believe that the most of all the target audience would have some of the takeaways and understanding so that you'll be able to get yourselves positioned in an architecture. So as in the morning in the keynote, as Madan mentioned, right? So today we have been developing applications in silos, but at the same time, the combination of the domain knowledge combined with technology is critically important. And Microsoft has been able to develop a lot of applications, technologies across each of the other components for the particular domains. And healthcare, financial services, there have been a lot of other components which has been specializing into it, and a lot of reusable frameworks out of there. So I would be taking a particular business use case, but this is just as a business view so that everybody gets a look and feel of an understanding of how a data is being categorized, what happens over there, what is an overall picture. Because even a business analyst or a developer, a quality engineer, we look at ensuring that a lot of pipelines, a lot of data are being unified from silos to a unification. But whereas a programmer, a developer, a quality engineer, he also needs to have a vision of where the complete component looks into it. That is very fruitful when you actually get to know things of debating that why is this particular tech stack? Why do I choose this? What is this? And what is that being compared against to multiple other cloud technologies? And it makes you much more comfortable to think around it. So I just thought I could give you a quick business view of this and then look through to see how I can overlay the same thing over a Azure cloud in comparison of a cloud technology so that it makes every one of you to understand what it is. So I'm sorry, I think, is it a little bit visible? Yeah, okay. So I wanted to put the thought and idea into you so that I'll walk you through. So the first thing that we always try to understand is what is your sources? You always have multiple. For example, if I look at a healthcare, right, I have data from a lot of other data. You can have batch data, which could be from the clinical, it could be a doctor's report, and then it could be a clinical a pharmacy information, a lot of batch data. It can be digital scan informations, which is all sort of a batch data. And then if you look at the real-time data, you have a lot of IoT wearable devices. Today, your Apple Watches, Google Fitbit, they monitor your sleep, a lot of metrics, remote patient monitoring data. So the data understanding is pretty important for you so that you get to know how can you get the data in what formats, because there are a lot of formats. We have gone past from CSV, JSONs, all Parquet and other files to sort of industry domain specific formats like HL7, CDC, and other formats. So in order for you to have that understanding, you would have to understand the sources first. So that's where we overlay saying what is your payer provider's data, and then you're able to look through where your batch or real-time data is. Now that you have identified the data, the next thing is the framework of how you could have the ingestion frameworks to load your data into. How well can your framework look to loading data? Can you have templates which can actually overlay things which makes it as a reusable component? Because for ages, we have been developing configurable things, which is more like a plug and play, so that it's easier for you to actually load the data and reduce the development efforts and start to use of the framework. And if you see here, it's again the same point of where we actually could look through. Now that you have ingested the data, you have to look at how are we going to do a processing of the data. Am I being able to process it from a raw layer, zoning, data zoning like a curated layer, consumption layer, or look at advanced analytics, or look at data science where I can look at data exploratory notebooks, which I have access across to data, or sort of I have a data management, which is more of a metadata management, lineage, data governance. So these are the lot of factors that you get into and how you move from that to start developing data products, because your end goal as a product is to develop products, right? Today we talk about 360-degree view, but when you don't understand your sources, your informations of how it is being categorized, you start to work in silos, it is very difficult for you to develop these products. Because a lot of times what we do is we start building from here, and then we start to look at saying, how do I get to scale up? So today's session is more about how a lot of the architectural best practices, which could be taken as a cheat sheet in terms of understanding things. So this is where you look at building up data products, and then after you've done with data products, you're basically ending up to analytics and reporting. So you're able to serve the data. It's more of a serving layer. You're able to cater the data which is being processed, which is being all curated, cleansified, and serving out to data. At the same time, there is also systems of engagement. So we have done through across use cases where there are elderly patients who have been able to get notifications on their insurance. Sort of that's how you're able to engage it. How well are you able to develop a product which has a health outcome or an outcome of which is being very beneficial in terms of returns. So there's a lot of other products which comes in, not where you're able to see a care management outreach or sort of a provider engagement. Very simple. We started very much earlier times when we had notifications in a telecom industry where when you go on a geographical change over there, there's been engagement over there. When you go into a cricket stadium, you get some notifications. There's always upsell and cross-sell over there. So that's the final engagement factor. That's where business comes into picture and how you look at it. So I wanted to quickly have this as a business view, and at the same time, look at it in a technological view. The same thing when you look at it as a business, now that I've understood things, how do I overlay that in a Azure cloud technology? So I can understand to see that I have my different sources of my data. At the same time, I'm able to look through a data ingestion pipeline, which is all through Data Factory. I have the event grips, and how am I getting my data? Is it my streaming data that I can integrate it with Event Hub? Or how batch processes could be brought in here? Where is my data? So once I have my data, we have moved edges from where we just stored the data into a data lake to a delta lake to a lake house. It's been an evolution of times because we have been trying to make the better use of our data. So in that aspect, we have been able to move that. And at the same time, when I said you about a lot of different tools that you start to take use of it by exploratory notebooks, understanding the data processing. So people have moved from where a data scientist or a business analyst or a QA engineer, as I said, right, quality engineers also have to get into technical stacks when they have to process or get this data to be tested. CI/CD pipelines and DevOps people also have to get into Databricks where they're able to integrate with data logs, Datadog, or any of the other sort of integrating applications. So it's become in such a way that there's no definite one single technology. It's more about a business use case. And it's always this way that you can always develop applications fast. But if you have to have your application running long with a bigger use case, sustaining with all the growth of all the velocity and veracity of the data, then you have to really make it with a very well thought. That's where it comes up with well architected frameworks and things where you are making more use of it. So as I mentioned about the data products and how you have your downstreams, which is more of your serving layer, and how well you would be able to cater it. And you have your management, which is pretty much where in Azure you have your tech stack with key vaults, you have your orchestration engines, you have your data catalog, policy, governance, and things that way. So this is just a head start for you guys to understand when we talk about technologies, where each of these components lay over and how you're able to vision it across to see it when you have a use case. When you talk about a technology, when you talk about a business case, this will be very helpful when you're able to talk about why do I have Databricks here? Why not I do have a Synapse there? Why don't I use a Snowflake there? No, every company is competing to be a different one. Databricks wants to be a data warehouse. Snowflake wants to be a data ingestion platform. So they have been very competitive across to do everything all in one. But how do you take it? It always goes well with your business use cases that you have to come do it. Okay, so now I'll go to the 6 architectural best practices, which I'll detail you guys more. Okay, so when I said is your data model compliant, right? So the first thing is, for example, if I take a healthcare data, right? The data is very much scattered. We are all pretty used to a way where whenever we look at a data, it's more of a project development phase where you get to say that when the source or the provider gives you the data, that is the source of truth that you look into. But definitely, you have to look out in such a way that you're able to understand the domain. If it's a healthcare domain, you understand what is the data, how is it being categorized, what it is, things and all. At the same time, when you have sources, it's not that it's a single source that you get data. With healthcare, you will have different insurance companies. So here in India, you would have ICICI, Lombard, and other healthcare providers. Each data would have different providers, different datas, and it would be the same thing, but it could have just a subset of it, a different naming conventions. We've always had issues with naming conventions and a lot of issues which we've seen. So that way, source and the target mapping is pretty much very important task where you're able to understand well of your data. At the same time, I wanted to talk about the standardization. So there are 5 standards which basically ensures that you have a better understanding of the data. When you say healthcare, all of us would have initially thought that it is only a patient data, it's a pharmacy data, it's more of a doctor's information of a information data, and then you'll have some clinical reporting. But how do you categorize all this? Is there is always standards to it. For example, if you see here over here, right, I have 5 standards here. In 5 standards, there is sort of things which it exactly tells you categorizing of your data, which says like, when you're talking about individuals, are you talking about patient, practitioner? Is it visible? Okay. So you're able to look through it completely over data. So if you see, I can see coverage, or if it's a billing thing, or a payment, or a general, or if I look at a medical records, how is it being categorized? Do I have a medical diagnosing? Do I have a medical substance? Or if I have to look at, if I go to an emergency medical record, where is it? Where is my healthcare? So it is very well categorized as a standard. So in that case, if you, for example, if I go into a patient, right? So I can have a clear standard of definition saying that exactly what is my fields which is essential over there. Because most of the time what happens is when the source sends you a subset of the data, you're trying to make that as the model. But that shouldn't be the way, because you have a standardization to say that if a patient model is there, these are all the list of informations that you get into. So that way you're able to build a canonical data model, and then you're able to fit it so that you don't have a lot of things. Though we have a lot of tools in schema evolution and all those things, we have star schemas to do that in different phases and all. But if you have this standardization, it has been very, very effective, because we have had effective development phase and a lot of productivity upgrades when we are able to sort of use standardization, and that literally improved a lot of our delivery phase, because we were able to engage directly with a lot of other business providers, payers, and things to exactly tell them or able to talk them that where is your claims data, where is this data over there. We were able to tell you them that we would be able to return you back in a fire standard, and these are the fields which you could consume or don't consume it. So in that way, we were able to have a better understanding of the domain, source, target, and standardizing it. Then we were able to move it across to insights, which is basically that when you put the data again over there, you have performance things where you're able to evaluate into a star schema, which is all more onto a demo. But the whole goal was that we made a bigger performance thing. When we changed it into a canonical model, we were able to have a complete mind map. So when a data quality engineer or anybody who comes in inside, he was having a very clear vision of what my data is going to look like. Because today, the best practice that I had in my our team, and we enforced it, was to every individual needs to look at what he is developing, what he is looking at, what the data is supposed to be. So now that when he had a clarity that, oh, this is the data, this is a practitioner information, this is a diagnosis information, so that we were able to clearly define through the keys, that made a lot of rewriting of the codes to be minimized, because use cases which define saying that I never knew that this is a primary key, or this is certainly a sort of keys which is important for us to process data, right? There are a lot of business logics which will depend on certain fields, but if you have a better understanding of this, a lot of rewrites was being resolved from us. Ouch. Okay. Apologize for the network. So now that you have modeled your data, right? The next one which we wanted was how good is your data ingestion framework, right? Azure Data Factory is a fantastic ETL framework tool, a data orchestration engine. So it was very easy when it is able to ingest your simple data. It has a lot of integration features where you can actually get yourself on a very securely SFTP process of where you're able to pull your data from your SFTP sites, at the same time securely encrypt or decrypt. When you receive a file, you're able to decrypt it, and when you send a file, you're able to encrypt it, and at the same time integrations with key vaults for a lot of secrets. And at the same time, it's more of a metadata driven framework which helps you in terms of increasing the productivity. Like you have multiple sources of data, you're able to sort of schedule that data approach, you're able to make use of those frameworks in a lot of examples where it's pretty straightforward over there. For example, there were cases which is very common across everywhere is you actually have a lot of batch processes. You will have a lot of streaming processes. So you look at, we've always seen that there's no finite or a place where a job orchestration engine is perfect over there. But ADF starts it with a very simple framework where we have resolved a lot of job conflicts and things and all, where it is a simple drag and drop of a configs. It has all the metadata driven things. You're able to sort of have a master pipeline where you can actually schedule things. For example, you could get in all those informations, sequence out a batch job. At the same time, you could actually start and stop a Databricks job as needed, or you can have a lot of file archival information. So you're able to put in every feature into it as one pipeline, and you're able to take it. At the same time, we've also integrated it with Microsoft Dynamics. Not just my Dynamics, I'm just highlighting here, but it has a very rich set of integration with a lot of tech stack. Dynamics is when we had for legacy systems, a lot of things. Dynamics, actually, Microsoft Dynamics, the loading system relies on the core loading of the data. But with ADF, we had this very easy options where when you had that sort of the entity relationship understanding, we were able to easily load it, as well as it was very usable with the logging, auditing, and sort of the monitoring information, which is within the ADF that I mentioned as well. Because when you have a file, it is able to sort of load it, and it is able to show you across things. And we have had a lot of CI/CD best practices where we have developed ARM templates and sort of how this can be reused or deployed across to multiple other environments and stuffs over there. So I can show a quick look and feel of Azure Data Factory. So I'm sure all of you guys are comfortable with the Azure portal and how you guys are able to navigate into the Azure Data Factory. So this is just code snippets and examples for you to show how this tool has been very easier and things that way. Sure. So I'm running short of time. um, sure. So here's where you'll be able to show through LinkedIn services where you're able to see the complete market stock over there. And at the same time, you have triggers, which is basically where you're able to look in when a file comes in, right? There are event-based triggers, there are scheduled triggers, you have jobs which can run out over there. At the same time, there are pipelines, which is basically able to sort of get yourselves to do certain things like I want to clean up my file. I want to do some integrations with Databricks to actually encrypt and decrypt a file. Or I want to have all of that in one pipeline where I'm able to do a pre-processing data dictionary checks and I'm able to load that data across two things and all. Same thing across when I can actually have a sort of a master pipeline which is able to sort of ensure that I have a list of batch jobs, streaming jobs. I can sequence it across to do things as well. Okay, I will quickly jump over to the slides. Um, So now that we have talked about data factory, right? Databricks is pretty much where you talk more about data acquisition, where uh, when you have to load your data, right? There's a lot of data dictionary validation checks because you've understood your data, you have your schema checks over there, you're able to sort of have a validation framework. And how Databricks was very helpful for us was we were able to have a data dictionary frameworks, and then we were able to have a pre-processing engine which was able to identify the bad records, isolate the records so that the process is more automated, and then we are able to do a data transformation on the good records. And then if you look at a data custody, which is basically the data isolation across to raw, curated, and consumption layer, and also a lot of archival processes. We have all known about this. I can go more detailed onto it later, but we were, as I mentioned to you about the common data model, right? That was a very beneficial structure over here because you understood the data well, so you exactly know how business layers to be there. But now that you have understood the data, we also used it for a lot of change detections. So when a data comes in over there, you're able to understand how is the data being, it's a new record, whether there was a demographics changed over there, what sort of event change data detections, and we were able to get all that for thing. And at the same time, when we had data across from multiple sources, right? You have multiple sources, you have to have a ranking algorithm which is able to say that what is the weightage that I have to take this source data to be preference over this one. And we had a very generic templates and all, ingestion framework sort of a thing, similar way, a pre-processing engine and a ranking algorithm in Databricks, which was pretty much very reusable components. I can show a sort of a code walkthrough snippets towards the last if I could finish and have some time. And we also have, as Databricks has been a very powerful engine in terms of IoT integration. In healthcare, a lot of wearable devices is all integrated, and how Spark Streaming was able to collect through all multiple observations data, and at the same time, how we were having heavy peak traffics. This is all volumes, which is all in real-time data, like a 500K members information, large volumes of data, how we were able to sort of enable it with Event Hub partitioning, the throughput, or the Spark Streaming job cluster informations. And the Cosmos DB was more of the API integration for the consumer apps and other applications to get into use it. And Azure Functions as well over there. And we also had data science, which is more of an exploratory notebooks where we are able to look through this data in different phases of it, as well as run through a lot of AI and things which can do advanced analytics and things. Okay. I'll walk you through the other points and then come back again to show you a demo of Databricks and things as well. Okay. Uh, now that we have seen the processing engine of Databricks to be very hardful thing, the major problem that we always face is you have data from multiple sources, right? The same data from multiple providers where you have like your phone number, address, everything, but whereas your identifier is different for that. It is a major problem that you're trying. So we evolved through a generation where it was more of MPI to EMPI to UMPI. Verato was a fantastic solution where we were able to use of the UMPI as well as your social determinants of health, SDOH data as well. We were able to make use of that where, for example, you have batch data, right? So you already have your production data, which is 500K of patients, information, all those things. That is from multiple providers. So you take all that data, we were able to put that through an integration engine to Verato, generate a linked ID for it so that you have a logic. So Verato was able to use referential matching, which is based on a very selective few fields, and it is able to identify that a same XYZ of a name living in a society with a different ID. It's able to match that algorithm over there and make that way. So you get a link ID. In our applications, when you get your data across from different things, like whenever a data comes, first thing is you identify whether it's a new data or it is an existing data which is updated. So those were the selective fields which you are able to sort of take them up, and then you are able to sort of use the Event Hub stuffs, and you're able to identify those events, and offline integration you're able to sort of integrate and then get it into this way. This is a very critical thing for us because when we were looking at sort of a customer 360 initiatives in terms of ensuring that you unify your data, only then it has been very helpful. Otherwise you have multiple copies of your data and such issues. So this was a critical thing which we were able to use Azure Functions, Event Hub, Spark Streaming, and sort of our classifications to get it all over there here. And now that you have had your data, the fancy stuff of into the Snowflake as well, right? So Snowflake, you have had this data into the cloud, but how well are you being able to use it? Are you being able to scale it, manage it, and get in meaningful insights? That's where this Snowflake comes into picture. So it's very simple point where you have your integrations with ADF, Azure Data Factory. You fetch your data from your blob storages or other places, and then you use Azure Data Factory to load that data into a copy. And in Snowflake, you use that as staging layers. You also have multiple stages here and schemas where you have it like a raw layer, which is basically staging of the data. Snowflake has an underlying of ADLS or S3. It is compatible with multiple clouds information. So you pick that into sort of the other ingestion layer and then the serving of the data. And then here, when you have analytics schema, which is able to get it curated of the data into the schema, you're also having a Power BI integration where you're able to get into visualization and reports information. At the same time, if there are certain things where you want to, this is on the ingestion framework into Snowflake, but if you want to look at how you're able to extract that information across also, you can use ADF where you're able to get that data and push it across. And if you want to do it through more of a secure process and things and all, you put it into the Delta Lake or have it access across to destinations through ADF as well. So Snowflake is a very powerful tool. We have used it on a lot of performance things and all. The integrations of it is very rich. You're able to sort of integrate it with a lot of programming skills into it. Right now, there are sort of integrations with a lot of coding into it is also available. And as a performer, it has been very good. It has been data sharing across to multiple other clouds. The analytics and the insights that we are trying to drive it out of it is very huge as well. I'll show you a demo of a Snowflake look and feel as well. I'll walk through, I think, running out of time. I'm really sorry because picking up each component of a topic is going to be huge and it's not easy to get that all. My objective on this today's talk was to make everybody vision how the architecture looks like and how each of the technologies are there. So that drives you to a lot of discussions that are. So now that you've had things, we've had a better infrastructure things with a lot of CI, CD integrations. So we were able to code, build, release it, test, monitor using, we were able to develop a lot of ARM templates. So you develop your pipelines in Azure Data Factory, you develop your notebooks in your Azure Databricks. We have ARM templates which is able to release it seamlessly into higher environments, because gone are the days where you're able to sort of manually look into your data and things and all. So you have to ensure that you develop it in your programs and it is able to have a seamless integration of your Git, which is able to take through all those templates, deploy it across environments, have its own sample data, which is able to test, reproduce and things and all. So this is where we were also able to sort of get more into it with the diagnostic settings, log analytics, job orchestration with a lot of the power of Azure DevOps. So we were able to scale that up. And there was a lot of best practices, common standards, templates, where we were able to sort of use it across multiple domains and multiple projects. And if you look at the last part of it to be onto the analytics and recommendation engine, right? Today, all of us are visioning into the AI and ML models, and how we look at it as more of a planning and the code, and how we are able to use Azure ML Ops to look at those data as well. So when we looked at those data, it's always that with the healthcare data, or be it to any other data, right? Today in healthcare, you have IoT data, which is wearable devices. We were able to sort of monitor sleep metrics, patterns of data. We were able to do a lot of data ingestion of different measures of blood pressure, sleep metrics, things and all. So once you get that data, right, and same thing with telecom and other automotive industries also, we have telemetry data and a lot of things. So we had comparative slides in the last where we can talk about how you're able to correlate. The main point I brought in the architecture was for people to correlate it and understand more of things. So the whole point is you're able to bring in a lot of insights when you combine the domain, which is the healthcare, as well as with the technology to bring in a lot of better decisions. So here, with the wearable health monitoring devices, we were able to take in for anomaly detection or classifications to actually bring in early disease detection or recommendations based on your user profiles and events and clustering. because it looks very simple that you're doing a lot of profiling, but with Verato, you're able to sort of isolate the duplicates and make it more meaningful. And vision, a lot of clinical data, right? You have that sort of records which you're able to scan and have more of advanced from the medical records, right? A lot of your reports and things. At the same time, we have also had ML accelerators, which is the complete life cycle of the development, and how all of this is sort of automated, accelerated. It's more like a plug and pay. So then in the near future, it's more like a person brings in a data in a USB sort of a thing. I'm not saying USB because it cannot bring it. But if you bring in a data which is more of a plug and play, when you bring in a data from any domain, I'm able to tell you exactly like what meaningful insights can I get in. Because when a top management guys, they really want to understand what can I do best out of the data, right? As a earlier time when we talked about NFRs and other things, because that's where people talk about it. But when we have to bring in meaningful insights, how well do you get it? Is where you bring in all this accelerator, because you used to do a lot of programming, a lot of lines. Now we have got drag and drops, we have got plug and play. So literally all this comes to a plug and play and accelerators. And as we talked about templates, frameworks, thing and all. So all this comes out to a point where you're able to bring in sort of a omni-channel multi cloud platform and a data product, right? A more of a 360-degree view. So when we are able to get in a patient's information, we were able to put that like a patient's identity information. He gets to see all his demographics information. He's able to see his coverage information when he lastly visited. Be it into a telecom also, when Apple Care, right? When you go inside, you get your Apple ID. You're able to sort of look out through saying that what was the other different products that you brought in, what was the complaints that you registered. So end of the day, we are trying to unify data which is being developed in silos of multiple projects into a single product. And that's the difficulty where we are trying to unify it. So we talk about data. At the same time, we talk about pipelines also, because a lot of projects are being developed as silos. Then there are monitoring and orchestrations which are being difficult. So we are trying to bridge that all. So unifying it, getting it to a very well-architected framework, you're able to sort of increase the business operations, sales, marketing, relationship. So you're able to sort of holistically get it into a bigger picture and then get it all into a beneficial way, which increases revenues and brings in for health outcome. So this is look and feel of a Databricks thing. So we were able to sort of get in functions, schemas, all those things, because I talked to you about pre-processing, data dictionary checks and all, right? So we were able to get all that information so that when we are able to sort of need a pre-processor, it's very simple and straightforward, where you actually run through this as a framework, irrespective of your sources, right? You're able to sort of get into your data, you're able to run through that things. And if you want to encrypt data, or you want to sort of decrypt data and you want ADF integrations to it, or you want some data validations, which is more of a schema checks over there. And at the same time, we are talking about configurable things where so this is sort of the IoT templates that where we have Spark streaming jobs, which we are able to integrate, fetch in data, any of the IoT devices. We are able to put that, read it from the event hub, load it into the Delta Lake, and sort of use the power of it. And we also had pointers where we are able to sort of define, when I said about multiple providers, right? Data from multiple sources and other informations and all, how you could bring in ranking algorithms, where you're able to sort of say that I have a logic, which is basically saying that this is where my conditions, this is my patient data coming from a source 1, source 2. This is the field that needs to take weightage. When I say my last name has to be always prioritized from this source, correct? And it can be customized across for each patient and each member also. So for that, when you have a very generic template which has the power of the functions, right? The pre-processing thing is always the power of it. So we are able to sort of get that into template. So Data Factory and Databricks is a great combination to that. And at the same time, this is a look and feel of Snowflake as well. So when you have data, right, you're able to sort of load it into the ingestion or the raw schema, which holds on to the raw format of the data, and then you're able to have it into the ingestion schema, and then you have core and analytics schema where you're able to integrate it with Power BI. You're able to sort of things on the field. So, and this is highly scalable as well. So you have easy ways where you can go. You have a bigger, huge data set, and you want to just scale it on a small warehouse or a bigger, larger warehouse, all those things. It's just a click away of an options here where you're able to sort of get all those data sets. And this also has sort of a snow site, which is more like you're able to sort of get into a lot of insights, dashboarding, and in terms of marketplace integrations. And it's pretty much where you're able to look through all those data sets, or even if you want to do any of those sort of query algorithms where we want to go look to see how well has my query performed, right? We can have the statistics informations over here in terms of how the query has taken it, how long has it taken, what has been there, the explain plans and things that way. And this is also where the Snowflake, you could have data sharing. We always spend a lot of time where we are able to have a data cloned from your dev environment to a test environment or migrating of other environments. So this makes it much more easier where you have data sharing capabilities not within a account, across account, and also with multi-cloud technologies where they are able to come out through things as well. So do I still have time? Done? Okay, sure. Um, okay, I think I think it was a little fruitful. I wanted to. The whole vision is to bring in an end-to-end solution so that you guys understand and how it is being all over there and how you are able to fit in places and things. Thanks a lot.